The Graduate Record Examination, also known as the GRE, is a test recorded for admission to many U.S. graduate schools. Student scores on the quantitative portion of the GRE follow a normal distribution with mean 150 and standard deviation 8.8. A graduate school requires a student score above 160 to be admitted. So let's write down the important information. So we have a mean of 150 and a standard deviation of 8.8. So we want to know what proportion of combined GRE scores can be expected to be over 160. So we're looking for the probability that X is greater than 160. So we're going to go into StatCrunch and go to Stat, Calculators, and then Normal. I'm going to slide this over just a little bit. So Stat, Calculators, and then Normal. And so our mean here is going to be 150. And our standard deviation is going to be 8.8. And we're going to type in X is greater than or equal to. Since greater than is not an option, and that's because it's a continuous variable here, and so the probability is exactly that value is 0. So we're going to type in greater than or equal to 160 and hit compute. So this is, oops, so that's what we're trying to find. So this is approximately equal to 0.1279. So the next part we want to know under 160. So now we're going to look at the probability that X is less than 160. Right? Just going to change this to less than or equal to. You notice if I add these two together, I get 1, and that's because they're complements of each other, right? So either you're greater than 160 or you're less than 160, right? So I could have just did 1 minus the previous answer to get to that. And our last part here, we want to know between 155 and 160. So 155 is less than X is less than 160. So we're going to click on between. And this is going to be 150. And this will be 160. And we're going to hit compute here. So this is approximately 0.3721. Alright, so very similar to what we were doing before. So this portion here, we want to know the probability that randomly selected student will score over 145 points. So we're looking for the probability that X is greater than 145. Right? So maybe pause the video, see if you can get it, and then do the same thing for part E. So try to write out the statement on your own, pause it, and then come back and check and see if you've got it. Right? And then less than 150. So I'm just going to go ahead and write this out. And let's see what we get here on StatCrunch. So back to standard. Greater than 145. So here we're getting approximately 0.7150 and less than 150. This is 0.5, right? And then you probably are thinking, well, that's strange, right? But then let's think about it, right? 150, what is that? That's our mean, right? So it makes sense that 50% would be less than the mean, right? So these are a little bit different here. Okay? We're starting to talk about percentile. So kind of going back and looking at our earlier chapters. So percentile rank of a student who earns a score of 142. So if we're at a certain percentile, we're at that score or below, right? So let's draw in a picture. So if we're at 142, 142 is about 1 standard deviation below. We're at that score, right? Or below. Right? So we're trying to find what this area equals, right? So we want to know what is the probability that x is less than or equal to 142. Right? That's what we're trying to find here. So less than or equal to 142. This is approximately 0.1817. So we're at about the 18th percentile. If we score 142. So historically, the Department of History at NYU has admitted students whose mean quantitative GRE score is in the 61st percentile. What is the mean GRE score of the students they admit? So this is kind of reverse of the problem we just did. So we're at the 61st percentile. So we know we're above the mean somewhere. So we're looking for the data value that corresponds to that. So we know in this case, this time, that our area is 0.61. Right? We have our mean, our standard deviation. We're looking for the probability that x is less than or equal to some value, and that is equal to 0.61. So I'm going to change this to 0.61 and hit compute here. This is approximately a score of 152. So 152 is about at the 61st percentile. Right. So another percentile question. We want to determine the 80th percentile. So this goes back and is very similar to part G here. Right. So the 80th percentile here. Can't seem to draw straight lines today. So 80th percentile. Right, so we know that this portion over here is 80%. Right, so our shaded region here is 80%. So we're looking at the probability that x is less than or equal to some number is equal to 0.80. Let's use StatCrunch here. Mean is still 150, standard deviation is still 8.8. Probability that x is less than or equal to something is 0.8. And compute. So we get about 157 here. So you can see that score that they want to admit is 160, and we're still not there at the 80th percentile. So you just score pretty high on their exam. So last portions here. We want to determine the GRE scores that make up the middle 95% of all scores. So the middle 95% of all. So let's draw on a bell curve here to help us out. We have the middle 95%. Right, so this is our shaded region, and we're trying to find two values. So not quite as easy as the z-scores we did, because one's not positive, one's not negative, since we're not working with z-scores, but they're symmetric about the mean, so the same distance away from the mean. We know they should approximately be about 2 standard deviations away from the mean. So we're going to kind of compare that in the next part to the empirical rule. So we can use, again, our normal calculator in StatCrunch. And our mean is still 150, standard deviation is still 8.8. So we're looking for the probability of some values. And that is rated by 95. So we're going to put in 0.95 here to find those values, and we get 132.75 523 and 167.2477. So those are our two values. And you'll notice here, if we go in and we take our mean of 150, and I subtract my value of 132.7523, the value, I'm going to take the second value, this is large, I'm going to use it first, and then I subtract my mean. They're the same distance away from the mean, which is what you expect, right? So now let's compare that to the empirical rule. So empirical rule says that the middle 95 are 2 standard deviations away. So I take the mean and subtract 2 sigma, and take the mean and add 2 sigma and compare here. So 150, so 150 minus 2 times 8.8, and 150 plus 2 times 8.8, and let's see what we get here. So 150 minus 2 times 8.8, we get 132.4. And if we look at it here, that's pretty close, right? And then I'm going to press second enter, and then I'll pull back up what I just typed in. I'm just going over and changing my minus sign to a plus. I get 167.6, which is pretty close here, right? So rounding, they wouldn't round to the exact same number, but they're pretty close to what we actually have there. So you can see empirical rule was approximately, but you can see those values are really close there.